Hey, this is Mr. Masonette, and what we're going to do today is we are going to find the surface area of a right rectangular pyramid. Now, let's say you have to find the surface area of this object on a test or something like that, and you completely forgot what the formula is. Well, if you do know what the Pythagorean Theorem is, that will allow you to figure out what the surface area is of this object. So if you do not have the Pythagorean Theorem memorized, then I would suggest going online and finding a tutorial about that first, and memorizing how to do that before figuring out the surface area of a right rectangular pyramid. Well, before we actually solve, let's go over a few basics about a right rectangular pyramid. The first thing that we should be aware of is that we have 5 surfaces. One of those 5 surfaces is our rectangular base, and then we have 4 triangular surfaces on the side. Now, because a rectangle has opposite sides that are congruent, that will give us 2 pairs of congruent triangles. So if you take a look, we have this larger triangle right here in the front, and the one in the back would be congruent to the one in the front, because you see the edge of this rectangle is 8 meters, so the base of this large triangle is 8 meters, and the one in the back would also have a base of 8 meters, so those 2 triangular surfaces are congruent to each other. Now you notice on the side here we have a skinny looking triangle, and that one has a base of 4 meters. And because opposite sides of any rectangle are equal in length, that also means that the triangles attached to those sides with a rectangular pyramid would be congruent to each other. So this triangle right here is going to be congruent to this triangle right here. So basically what we're trying to do is figure out what is the area of the 4x8 rectangle, and we are trying to determine the area of the 2 triangular surfaces that have a base of 8 meters. And we have to determine the area of the 2 triangular surfaces that have a base of 4 meters. So what we're going to do is we are going to find the area of each one of these 5 surfaces and then add them together. Okay, so starting with this rectangle right here, we know that it is a 4x8 rectangle, and 4 times 8 is 32. So we know that the area of the rectangular base is 32 square meters. All right, let's take a look at this single triangle right here that's shown in the front. Now, to figure out the area of any triangle, we should know that we have to multiply the base and the height of that triangle and take that result and divide it by 2. Well, we already know what the base is. That's 8. However, the height of this triangle is not shown. We have to be careful here because this 5 right here is not the height of this triangle right here. 5 is actually the height of the entire pyramid. So if you were to start at the top of this pyramid and go right through the center of the pyramid until you hit the bottom, where this line forms a right angle, this is the actual height of that pyramid. Now, what we're looking for is the slant height of this individual triangle. And it really should be noted that with a rectangular pyramid, that the slant height of this triangle or this surface will be different than this one up here. So don't think that once we figured out what this slant height is, that we know what this one is. We're going to have to find those individually. So to figure out the area of this triangular surface, we're going to have to figure out the length of this line right here. But one thing that we should note is take a look at the height of the pyramid, which is 5 meters. The height of this pyramid with this line segment right here would form a right triangle. And the Pythagorean theorem states that if you know the length of 2 of the 3 sides of any right triangle, you can find the third. Now we can see that the length of this side of our triangle is 5 meters because that's also the height of the pyramid. But let's take a look at this triangle's leg right here. Now we should know that this line right here has a distance of 2 meters. Now the reason that we should know that this is 2 meters is because from this point right here to this point right here would be half of the distance of this line segment right here. And because this is 4, this is 2. Because this line segment would be the halfway point going all the way across that rectangle. Now that we know the distance of the 2 legs of our right triangle, we can calculate the distance of our third side, or the hypotenuse. So the Pythagorean theorem just says you have to take the two short sides of your triangle, the legs of your triangle, and square them together. And the sum of those squares will be equal to the hypotenuse squared. So we have 2 squared, which is 4, plus 5 squared, which is 25, and that will equal c squared. So 29 will be equal to c squared. So to figure out what c is equal to, we just have to take the square root of 29. And the square root of 29, if I round to the nearest hundredths, is equal to 5 and 39 hundredths. So almost 5.4. All right, now that we know the distance of this triangular face's height, we can take that and multiply it by this triangular face's base and then divide it by 2. So we're going to take that triangle's base, which is 8, multiply it by 5.39, and then divide that by 2. All right, next I'm going to take this 8 here and divide it by 2 first. And of course, 8 divided by 2 is 4. So now we have to multiply 4 by 5.39. And 4 times 5.39 is 21 and 56 hundredths. Now remember, this value right here was an approximation, so the area of this triangular face right here is approximately equal to 21 and 56 hundredths. So for this triangular face right here, let's just label that 21.56 square meters. And because this triangular face is congruent to this one, the area of this triangular face is also 21.56 square meters, leaving us only with the area of these two surfaces to calculate. Now we know for this triangular surface what the base length is, that's 4 meters, but now we have to figure out what is the slant height of that triangular face. Now we already know that the base length of this triangular face is 4 meters, but what we have to do is figure out what is that triangle's height, or what is the slant height of that triangular face. Well, we can see that this line segment right here, this line segment here, which is the height of the pyramid, and this line segment right here would form a right triangle. So what we have to do is figure out what is the distance of this line segment. This line segment is already given, that's 5, and then use the Pythagorean theorem to figure out what the length of this hypotenuse is. Well, this line segment here is 5, so let's go ahead and square that. And then we have to figure out what is the distance of this line segment here. Now, because this line segment right here is 8 meters, that just means that this line segment right here is 4 meters. Because if we were to extend this line all the way across our rectangle right here, that would have a distance of 8 meters, and this line segment is exactly half of that. So we can label this line segment right here 4 meters. So let's go ahead and plug that into the Pythagorean theorem. Now we can figure out what the value of c is. So now we have 25 plus 16 equal to c squared, and 25 plus 16 is 41. So to figure out what c is going to be, we have to take the square root of 41. And the square root of 41 to the nearest hundredth is 6.40. So we can just go ahead and say that this line segment right here is approximately equal to 6.4. All right, now that we know this triangle's base and its height, we can go ahead and figure out what the area is of that triangle. So what we're going to do is multiply 4 by 6.4, and then we divide by 2. However, we should note that both of these triangular surfaces are equal to each other. So whatever answer this is, the other triangle is going to be the same. So basically, we're going to take this answer and double it. So we can take this whole quantity here if we wanted to and multiply it by 2. And notice if we multiply by 2, we have a 2 for a numerator and a denominator, so we can cancel both of these out. So multiplying 4 by 6.4 will actually give us the combined area of these two triangular surfaces. So let's go ahead and do that. Now, when I multiply anything by 4, I just like to take that number and double it twice because that's the same thing as multiplying by 4. So if I double 6.4, that would be 12.8. And if I double 12.8, that would be 25.6. So the combined area of both of these triangles right here is 25.6 square meters. So if the combined area of these two triangular surfaces is 25.6 square meters, that just means that the area of each individual triangular face would be 12.8 square meters. All right, now we have all the information we need to get our final answer. So we have to add 32 to 21.56. And of course, we have another 21.56. I could have just doubled that first if I wanted to, but I'll just leave those separate for now. But 25.6 is actually these two surfaces combined. So we have the area of all 5 surfaces represented right here. So we're going to go ahead and add those values together. So let's go ahead and add a decimal here and put zeros in our blank spaces. All right, so this column right here is a total of 12. And right here we have a total of 17. And right here we have a total of 2, 4, 5, 10. And right here we have 2, 4, 6, 9, 10. So we would say that the surface area of our right rectangular pyramid is approximately equal to 172 hundredths square meters. Notice when I was using the Pythagorean Theorem and I took the square root of a value, I actually used some rounded values. And if you were to use certain online calculators, or if you were to use your calculator, you might end up rounding it differently or to the nearest hundredths place, thousands, 10,000ths. And obviously, the more places you have after the decimal, the more accurate your answer is going to be. So my answer could be slightly different than things that you guys can see online. But that's why I put approximately equal to, because it is really, really close to that value. All right, so there you have it. We were able to successfully find the surface area of a right rectangular pyramid. Hey, I just want to say thanks very much for checking out my math video. Please subscribe to my channel so when I upload new math videos, you can become informed as they become available.